Hi, Algebra. So far, we have been looking at lines this unit. Look, here are some lines. And we've been talking about lines in really having kind of two components, that lines have slope and y-intercept. And we've been talking about the slope representing how much we rise over how much we run. The steepness of the line is really counting how much we go up and dividing that by how much we go to the right. How much we go up, how much we go to the right. In this case, I'm going up 3 and to the right 1, or I could say my slope is 3. The y-intercept in this function is 0. It crosses the y-axis at 0. And then we can take our m and our b and write an equation for the line, y equals 3x plus 0, or just y equals 3x. We might look at a line with a negative slope. This has a negative slope and it's, I don't know, sort of not quite very, not as steep as this one. And we might look at the slope and we might look at the y-intercept. For the y-intercept, I notice that it crosses the y-axis at 2, 1, 2. And I notice that for every point, from one point to the next, I go down 2 and over 3, down 2 and to the right 3, down 2 and to the right 3. So my slope is going to be negative 2 over 3. I'd write that equation, y equals negative 2/3 x plus 2. When I look at this equation, I notice I go up 1 over 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And that gives me a slope of up 1 over 1 or just 1. In this case, my y-intercept is 1. So my equation is y equals 1x or just x plus 1, where m is the slope and b is the y-intercept. Yesterday, we took a look at some other situations. Here, my slope is undefined. Remember the worst word, the worst swear word in math, undefined. And so when we have a situation like this, our equation will always be in the form of x equals some number. In this case, it's x equals 1, 2, 3. X is always 3. When y is 1, x is 3. And when y is 2, x is 3. And when y is 4, x is 3. X is always 3. We also looked at a horizontal line, I should say. This is a vertical line. We can also have a horizontal line. A horizontal line is flat like the horizon, and it is always in the form of y equals some number. And in this case, it's 1, 2. Y equals 2. We could also think about this in terms of y equals mx plus b, but in this case, m is 0. 0x plus b, our y-intercept is 2. Y equals 2. But so far, we've really been looking at the graph to determine the equation. The points have been fairly easy to count. Down 1 over 2, down 1 over 2. But what happens when the points are not so easy to count? Look, these points are far away from each other. How on earth am I going to figure out the distance between the point 2, negative 2 and the point 5, 10? How will I do it? Well, I could count, or I could use a shortcut for counting. Counting is not particularly algebraic, right? It's just sort of like counting. Like we know how to count. We did that in first, second, third grade. But here, look, if I'm trying to go all the way up here, all the way from negative 2 to 10 to figure out my rise, how much am I going up? Well, I'm going up from here to here, I'm going up 10. And from here to here, I'm going up 2. So I can kind of skip count and say, well, I'm going up 12. My rise is 12. How much am I going over? Well, that one's easy. I'm going to the right. I'm running 3. And so then my slope I can calculate at 4. But I don't know, guys. There's got to be a better way, right? Like, I want to figure out how I can do this without having to make these marks. How can I get from 10 and negative 2? How do I get 12? How do I get from 5 and 2 and get 3? What process is happening? Well, I'll tell you. The process is subtraction. Remember, we're trying to find the difference between these 2 points. Difference means subtract. So if I subtract my y's, if I find the difference between my y's, and then I find my difference between my x's, I'll find my rise and my run. Sometimes we talk about slope as being rise over run. Sometimes we talk about it as being the change in y over the change in x, which means we're subtracting the y's and we're subtracting the x's. Now, to keep things clear, I'm going to name these points. I'm going to name, this is my first point, I'm going to name this x1 and y1. This is point x1, y1. And this one over here, this is x2 and y2. And if I'm going to find my difference, I'm going to subtract my y's, my y2 from my y1. y2 minus y1. And then I'm going to subtract my x's, my x2 from my x1. x2 minus x1. Now here, look at what happens when I have my points 5, 10, and 2, negative 2. If this is x1, y1, and this is x2, y2, watch what happens. When I plug this into my formula, y2, 10, minus y1, negative 2, over x2, 5, minus x1, 2, look at what I get. 10 minus negative 2, when we take away a negative, that's like adding a positive, we get 12. And 5 minus 2, 5 minus 2, 3. Now you start to see where our 12 and our 3 come from. Then the only thing we do is reduce. 3 goes into 12 4 times. So now we don't have to fuss with all of these graphs. We can just subtract.